we are going to deal with the SolidWorks CAD professional course. Okay, in this particular course there will be on an average 23 sessions. Okay, so we are going to deal with the first session. So as we will be going with the basics here, the first one, the introduction to CAD, what exactly it is, so basic terminologies which we use in the particular CAD, and then introduction to constraints, degrees of freedom, introduction to SolidWorks UI and the shortcuts, how we need to configure the shortcuts, and finally we'll see the SolidWorks background settings also. Okay. Yeah. So now, just a basic question. So what is CAD, Annie and I think Yogesh? So what do you think practically? Don't refer this particular statement and all. You just tell me what exactly you meant about CAD.
CAD is 3D software to create the digital design, to convert a theoretical idea into a practical.
Okay. So what about Annie?
Practical model.
It's used to make blueprints for the machines and all, everything.
Okay.
Design and blueprints here.
Yeah, I think it's pretty good. So in short, this CAD is nothing but it's a computer aided design. Okay. Currently, in current generation, we are using softwares to create design or geometry or whatever it is, optimal design, by using the CAD tools like the SolidWorks and NX, CATIA, okay, Fusion 360, Autodesk, okay, a lot of softwares are there. We use these softwares to replace the manual drafting. Okay, before I think 20, 30, 50 years before, so we used to do it manually. Okay, there will be a lot of people, so draftsmen who used to do this by using the the draft sheets. But now we have this tool where we try to design everything and try to store it and try to implement for each and everything. Okay, basically we use it for all the domains like automotive, industrial equipments, okay, and the aerospace. A lot of domains it is widely used. Yeah. When it comes to key benefits of CAD is, so what exactly we can achieve is the preciseness and the consistent design. Okay, and very important thing is the faster revisions and iteration. So if you have design ready, you don't need to do anything, just get into that, make the changes. Okay, if it is a draftman era, they again need to redesign everything from the scratch. Okay, if they do a particular a length of 50 mm, so there should be some changes in the sense they are manually doing it. Okay, manually creating everything again, or this is what they used to do, so it is quite difficult that time, but now we can do these all the revisions within fraction of seconds. So storage is easy and we can even share to anyone anytime. Okay, and then when it comes to the same model, we can take it to the manufacturing and documentation as well as doing the simulation also. So a lot of advantages are there when it comes to CAD. Okay, now, so with respect to industry, now the current market, these are the very important tools which are running into the current market. The most of the cases I could see in India, the medium scale industries and small scale industries are widely using SolidWorks, okay, to design all the 3D models and doing the basic simulations. And then some of the industries like the what we could say civil, okay, that regions we mostly see this AutoCAD drafting tools. Okay, so for architectural designs and also they use it mostly. And then NX and CATIA are the top-notch tools which will be used in automotive industries and then aerospace industries because of their molding capabilities and surfacing, as well as the model handling capabilities like the PLM and everything is great in this particular tools. Okay, now Revit is mainly for the architecture and the BIM designs, just for information. So today we are just focusing on the SolidWorks. Okay, so yeah, key industries using CAD, for example, architecture, engineering, and construction. They're going to just deal with the floor plans and dealing with the elevations. When it comes to mechanical, they design the machineries, assemblies, and tools. Okay, they also do the analysis by using the tools like the stress analysis, buckling, NVH, durability, crash and heat, safety. This kind of analysis they do. Okay, same for automotive also. They try to design the interior, exteriors, okay, engine design, aircraft interiors, everything. Electronics and PCB, we use the PCB designs there. Okay, circuit layouts, we try to do it. When it comes to, again, product and industrial design, for goods, packaging, and modeling, we try to use them. Okay, so I think we mainly focus on this region, this domain, where we have the industrial designs and the mechanical. Okay, and we try to implement everything here, and it is also closely related to these three domains. Okay, automotive, industrial design, and the mechanical and industrial design. Now we are into the SolidWorks. So we already know what exactly the CAD is. So CAD is just a computer design and drafting tool where we try to design everything digitally and make the drawings so that we can make out the printouts and give it for the shop floor and other process, PPAP or other manufacturing process, FMEA process. Okay. Now, when it comes to SolidWorks, we could tell that it's a feature-based parametric solid tool. Okay, what exactly this feature-based and parametric tool? Does anyone know? Here we have the two, like the feature, key feature is the parametric modeling. Any information about this, the parametric modeling, what exactly it is when it comes to CAD tools? Any idea about it?
No, I don't have any idea.
Okay, so when it comes to parametric model now, I hope you could see the image here, right? So assume this is the corner block. Now I'm going to design this by using these dimensions. Okay, so once I'm done with the design, assume if I need to make the changes, instead of 70 here I would like to maintain 65. Here also I would like to make it 65. So what do we do exactly? We take the SolidWorks model, same model, we open it, we just directly edit this value to 70 to 65, automatically design will change. This is what is the parametric. So we can easily play with the dimensions and we can make the changes whenever we want. Okay. Example for parametric modeling tools like this, SolidWorks we have, NX, CATIA, Solid Edge, and CREO. But when it comes to non-parametric, we have the AutoCAD, because once you define the dimension there in the 2D drafting, you cannot change it, you need to recreate it. Yeah, that is non-parametric design. So we have the constraints. So what exactly constraint is? So in constraint we have two types, that is the geometrical constraints and the dimensional constraints, right? So can someone give the example for the geometrical constraints and the dimensional constraints? Anything from you? What do you think about the dimensional constraints and geometrical constraints?
When you make any changes might not geometrically correct.
So examples, any
Right.
geometrical constraints, examples, like any idea?
Examples.
Dimensional constraints?
No.
Okay, there's nothing big deal here. Assume we have the geometrical constraints. What exactly geometrical constraints does is they try to rectify the shape of the model in chart. Assume we have the parallel, right? Then we have the vertical, horizontal, concentric. So these all are the geometrical constraints, right? They try to fit the geometry in chart. Okay, when it comes to dimensional constraining, we have the length, width, height, right? And then we can take the angle. So these all are the dimensional constraints in chart. Okay, now when it comes to solid model, the straightforward question is, we have the corner block here. I have designed this in SolidWorks. Now, can I see that this particular corner block model which is there in SolidWorks is a real practical model? Yes or no?
Yes.
Okay, how can you say it is yes?
We can do analysis on this one, right?
Yeah, we can do, but assume you have designed this model. What about the material
Yes.
properties and all? Did you assign the material properties for this?
Yeah, when we do the stats analysis, we have to
Assign. Good. So
yeah.
if you assign the material for this, then only this particular model will be called as a practical real model, because until and unless you assign the mechanical properties or the geometrical properties for this, let's say to check the weight of the component, what do we need to have as a main mechanical property?
Material, which material we are using.
Yeah, so in the material we need to know what exactly the density is. Okay, then only we can able to compare. Assume this corner block is weighing 2.5 kg outside, and if you, it should be 2.5 in the CAD also. To get to know that, we should assign the density of the material. Okay, we're gonna assign everything, but density plays very important role. Is that clear? So yeah, we can even apply the appearance. We can even take do the analysis on this by just applying the mechanical properties. Okay, next one is the features. Okay, so there are two types of features. One is the sketch based features, next one is the applied features. Does anyone know about the features in CAD tools? What is sketch based features?
Once we sketched it and we used to emboss, make a whole part.
Good.
Which are called sketch features.
Yeah, extrude and then cut out, sweep. Okay, lock.
Yes.
Then what about applied features?
Applied features, no clue.
It's simple. The chamfer, it doesn't take any of the fillet, right? It directly take the feature into account. Then fillet, then shell, right? So these are all called as the applied features. Yeah, I hope it's clear, right? Is there any doubt in the slide?
Yeah. No.
Okay, good. So now we just spoke about the constraints, right? Before that, we'll see what exactly the parametric sketch is. So parametric sketch, in the sense, the sketch should have geometric as well as the dimensional constraint both, and that sketch should be fully defined. Means it should not have any constraints missing. All the constraints should be applied and it should be fully constraints. So assume, just imagine you have the rectangle. Okay, can I say assume? Okay, just assume in the 2D panel in XY plane you have drawn a rectangle. Okay, now you need to tell me whether that sketch is fully defined or not. Yes or no?
Dimensionally, in geometrically, yeah, it's fully assigned.
I just said it's just a rectangle. Okay, I haven't even assigned any dimension, right?
Okay.
So is it fully defined?
No.
So okay, now assume you have applied the dimensions for that. Okay, so assume we have 20 and 30 mm sidewise. Now is it fully defined?
Dimensionally, yes.
Okay, but my question is fully defined with respect to both geometrical constraints and the dimensional constraints. You have the XY plane, in that we have a rectangle for 30 by 20 mm is the dimension.
Yes.
Is it fully defined?
And squares. I think so, yeah.
No. If I say
angles.
No, if I say rectangle, definitely corners it will be having the angles, correct? And the side edges will be parallel. Rectangle is clear. Now we have also applied the dimensions, that is 30 by 20. It is geometrically dimensionally fine, but when it comes to coordinates, XY plane, it is freely lying. It doesn't have any reference from the origin, right? So we need to constrain, in the sense it is freely moving in XY plane. Am I right? So now you need to assign the constraint from the origin. You need to define the dimension from the x this much from y this much, then only it will be fully constrained. Is that clear?
Okay. Yes.
Yeah. So to make it constrained, so we are going to use the constraints where geometrical constraints try to maintain the shape and dimensional constraint maintain the size of it in short. Okay. Now, what is degrees of freedom? Any idea about it? The most important question everywhere.
It's the movement for the mechanism.
Yeah.
How many movements it has?
Okay. Assume we have a ball, not a ball. Assume what we could take. Okay. Everyone has the mobile, so we'll assume that the mobile is placed in this space. Okay. Now, the number of independent possible ways that particular mobile can rotate or move in the space is called as the degrees of freedom. Now, in short, if your mobile is in space, how many degrees of freedom it has? No idea?
Maybe 8.
Okay. So overall, there is only 6 degrees of freedom. Okay, whatever the component you take it, for each and every component, there are only 6 degrees of freedom. You could see 3 translation and 3 rotational. So when it comes to 3 translation, if you consider along x, so it should be positive and negative direction movement is called as 1 degree of freedom. Similarly, y positive negative, z positive negative. Similarly, rotation along x, y, z, clockwise and anti-clockwise considered as 3 rotational. Now assume, I'll just try to give you the practical example. So you might have the laptop with you.
Yes.
Assume you have the laptop. Now, with respect to practical usage of that laptop, how many degrees of freedom do you think the laptop has?
One.
Which is that?
Which is rotational.
Along which axis?
Along if this is x and y.
Okay, anything is fine, x or y as per your assumption. You're saying only one rotation it has, only 1 degree of freedom. But you do use the keyboards, right? So you're gonna press them. So we could take that also into account, right? So it should be along y-axis, the translation, okay? And then the rotation along x-axis. So in short, 2 degrees of freedom. Am I right?
2 degrees of freedom. Yes.
Okay, assume you might draw the bike. Okay, now with respect to practical approach, if you sit on the bike and you're riding, so you just consider the front wheel. Okay, and now you need to tell me how many degrees of freedom that front wheel has.
Front wheel has 1.
Which is that?
Which is the rotational.
Okay, good, but you gonna also try to what? Turn, right?
Turn right and left. Yeah.
So how many now?
But with the 3 left, right.
3, yeah. One is along the x-axis rotation, okay. Another is along the tilting along x-axis. Not x-axis, it should be z-axis. So I think only 2 degrees of freedom, right? Only it is rotating along x-axis and it is again tilting along the z-axis. Apart from these two, do you think anything you see?
No.
Good. So I hope you got to know about the degrees of freedom, right? In short.
Yeah.
Good. Now, so these are the few geometrical constraints as I was explaining before. the horizontal, vertical, okay, and then we have the midpoint, perpendicular, parallel, then we have the tangent, equal, collinear, concentric, co-radial, fixed, intersect, and the symmetry. Is that clear? If you have any doubts in this, you need to ask me anytime, so I can help you out. Okay, so mostly we use these all the geometrical constraints while defining or creating any of the sketches. Yeah. Now about the SolidWorks. So when it comes to a current era, the current market, the SolidWorks, basically in India it is used in most of the domains, I could say. Okay, even in automotive, aerospace, okay, the consumer products, industrial equipment, the manufacturing, everywhere I could see this is widely used. Okay, and now in SolidWorks we have three main packages. Okay, one is SolidWorks Standard, Professional, and Premium. So what are the differences? In SolidWorks Standard, you're gonna have the CAM tool with you, and the basic all the drafting capabilities will be there. Okay, now when it comes to the Professional, you will have the fasteners. Okay, all the nuts and bolts you could see here. No, you don't need to design them. In the SolidWorks design library, you can get this all the fasteners ready. Just you need to drag and drop it. Okay, it will give all the shape and size, formats, everything. This is the biggest advantage here. With that, you're gonna have the SolidWorks Visualize Standard, which is again free, and CAM is also with this, and some of the basic simulation these will be having it here. Okay, now in Premium, whatever the things it has here, along with that the simulation capabilities it has, the motion studies it will be having it. Okay, and yeah, so compared to these two, it will be having more features for CAD. Okay, is that clear?
Yes.
Yeah. Now we'll directly jump into the SolidWorks user interface here. I hope you could see, right? So this is the SolidWorks user interface when you load a model inside it, and you could see this is how it looks like. Okay, we'll go through this particular user interface, and later we'll try to jump what exactly these are. Okay, the first one is the menu bar. You could see on the top right. So this is the menu bar. Here you'll be having all the inputs with respect to saving the file, opening it, okay, rebuild, okay, settings. We have the command, we can search for the commands, we can go for the help, we can check the license details, everything we can do it in the menu bar. Okay, a lot of things we can do it in the tools and insert, but this is the menu bar, we call it on the top. Now the next one is the command manager. You could see this one. So in the command manager, you'll be having the tabs for each and every tool domains. Assume if I need to work on the sketch, if I just click on the sketch, the tools related to the sketch or workbench will be loaded here. So all the line, circle, everything will be here. Then when it comes to surfacing, sheet metal, mold design, these all will be the tools will be respected to that particular tabs. If you just click on that tab, you will go there. You can even configure this particular tabs. I can show that later also. Okay, this is about the command manager. Next one is the feature manager. Okay, in the feature manager we have the first one, the icon you could see, no, this is feature manager. Then this is the property manager, which we have it, and this is configuration, and then we have the GD&T, okay, MBD, and then we have the appearance. Okay, just remember, I'll try to explain these all things later also. Just remember what are the features are available in the feature manager tree. Okay, next one is the task pane. Okay, whatever you're gonna see at your right side is the task pane. In that we mainly have this design library. As I said, all the fasteners will be available here, and then we have the file explorer, very powerful. You can just go here and directly explore the files and drag and drop it here. You don't need to go to file explorer and bring the files. We have the drafting here. Okay, what exactly it does is it will have all the standard drawings. You just need to drag and drop it with respect to side, front, top, okay, isometric view, everything will be loaded here. Next we have this display style. So from here you can just drag and drop the all the appearances. I can show that later also. Okay, so a lot of advanced tools are listed into the task pane. Okay, as I said, we have the design library. Next is the heads up view toolbar. So this is frequently used every time while we design. So in that we have the section view, display styles, okay, and then the background settings. A lot of options will be here. Then I can just show these things later also. So these are the main domains in the SolidWorks user interface, and this is the graphics area where we try to model the required components by viewing, panning. Okay, a lot of things we do it here. Okay, is that clear?
Yes, clear.
Good. So you just need to remember these main terminologies. Okay, the first one is the menu bar, command manager, feature manager, and then we have the heads up view, task pane, and then the design library inside this, and the graphics area. Okay, so in the next session I might ask you about this. Okay, I can even share the slide or the recorded video of this session so that you can just go through that and try to remember these. Okay, next, so customizing the SolidWorks user interface as per your need. Okay, everyone can learn the SolidWorks, but the thing is, the person who is going to use it efficiently will benefit him a lot. Okay, if the person can, I think the normal person who will be trained somewhere else, who knows the basics, he might take 1 hour to design a particular component. If we give the same component to an expert, like who will be getting trained from the corporate trainers, he will take hardly 25 to 30 minutes to complete that, because he will be knowing all the shortcuts, how you need to play in the SolidWorks, so each and everything he will be knowing it. Okay, just for information. Next, first thing is the system options. So there are two important things. One is auto rotate view, normal to view, and then we have the enable on screen numeric input. These two are very helpful, so we'll see how to configure that later. The most important thing is the unit system. So you need to set up the default unit system as MMGS. If it is not, you need to make sure which unit system you're going to use it, and that you need to set it. Okay, and then keyboard shortcut, mouse gestures, and the shortcut pass. Okay, this is the keyboard shortcuts which we use frequently. Remember these: the I for isometric view, N for normal view, Q for insert sketch and exiting the sketch, trimming, circle, line, and smart dimension. These are the mouse gestures. If you want, you can customize it. This is the shortcut bar. Okay, I'll show these things later, how we need to configure. The last one is the SolidWorks backgrounds. Okay, we have the white theme and we do have the black theme. So whichever you prefer, you can just adjust it and try to use them. Okay. Now the next one is we'll try to go in depth and see how exactly SolidWorks looks like and use interfaces. Is that fine? Let's start with this. I'll just open the SolidWorks. So if you're the first time user, if you want to open the SolidWorks, you just need to go to Windows and search for SolidWorks here, and it shows you. You can just select this icon, or else you can simply right click on it and you can pin to the taskbar here. You could see it is pinned. Now let me just configure my taskbar behavior, or I would like to hide it. Okay, now you could see it is pinged here. Whenever you want, you can just click on this icon, or else you can come here and open it. Okay. Okay, so now once you open the SolidWorks, this is how it looks like. You could see we have the menu bar. This is the welcome window where you'll be having all the 3 standard templates, that is the part, assembly, and drafting. And we'll be having all the recent documents which you had already opened. Okay, and then you have the learn option. You can just go here and try to check these all. Then you have the alerts. Okay, whatever the new updates are available, you can check it here. And then these are all the recent files which I had used. Okay, you can just click on it so that it can be easily loaded. Okay, currently I'll simply close it. Okay, now you could see we have the task pane here. If I just click here, it will go and hide here. Now you can even just pin this option. Can you see on this on the top auto show is there? If I pin this, it won't hide. So you can just minimize it and you can just set it like this, and it will be here every time. Now similarly here also you could see there's a pin and unpin option. If I unpin this, you could see file view tools will not be visible. So if you want it by default, you can just pin it like this. Same here. Okay. Now how to open any of the standard templates. So for that you can use the Control N. Okay. Once you do that, or else you can click on this new icon, or else you can go to File and select New. Okay. If you do that, SolidWorks is all about these three templates. One is the part, one is the assembly, and then the drafting. Okay. Very important is the part where we try to design everything. Okay. And again, if you want to have the advanced templates, you can just go here and configure. I have only 3 standard templates. If you want, we can configure it later also. I can show that in the drafting session. Okay. I will mainly focus on the part. Just click on this part and just click OK. Once you do that, this is how the user interface look like. So as I said, the menu bar, the task command manager, the feature manager tree, everything. Okay. Very important thing is the graphics area. You could see I'm not okay with this. I would like to always have the white background. So what you can do is, here you could see now there's apply seeds. You can use this drop down and set it to white plain. Okay, this is how it looks like. And now here we have the standard 3 default planes in the hide icon, hide show icon. If you just click on this, it shows all the 3 standard planes. If you don't want it again, you can just use the drop down and you can just hide them. Okay. So now let me just take you through the background settings. You can see here the icon, right? Options. If you use the drop down, you have this SolidWorks add-ins. So here, as I'm using the premium version, these all are the add-ins I'm having it. Okay, SolidWorks simulation, routing, motion, photo view 360, okay, 3D experience, the visualize, flow simulation, and I have the cam. So these all are the add-ins. So if you want to use these tools, you just need to check this icon so that this particular add-on will be loaded and you can start working on it. Okay. And now here we have the icon size. So button size, if you want to make it large, you can do it. If you want to make it medium, you can even do it. You could see it got changed, slightly bigger. Would like to maintain it a small one, it will go back and it will make it small. Okay. Next one is the options. In the options, you could see there are a lot of things. One is the system options and document properties. I want you people to do the same. Open the SolidWorks tool and switch to system options and colors. Okay. In this you have the icon color is default and the background is light. You can switch to dark. You can even switch to medium, and you can even switch to medium light. I'll just show how the dark works and click OK. You could see everything changed to dark. Now in this you can even configure icons. So icon color is default. If I switch to classic, you could see now it is blue, right? If I switch to this, it will change to classic. Is that clear?
Yes.
Now one more important thing here is this one. So if you go to sketch, then you have this option. Can you see on the top, auto rotate view normal to sketch plane and sketch creation? What exactly it does is, let's say you have a sketch, you want to create it. If you select a plane and try to sketch on it, automatically it will make the plane normal to view. Okay, I'll just check this option. I'll show you how it works. And this is very important. Enable on-screen numeric input. So what it does is, while defining the dimension, it will give you the on-screen numeric input. I'll uncheck this one at the moment. I'll show you how it is going to work also. Now, assume I want to work on the front plane. If I just select this, and here you could see now there's a quick access icon. You can directly click on it, or else you can switch to sketch You can use this drop down, or you can directly click on this icon. It will give you all the 3 standard default planes. You can select whichever the plane you want to work. Now I want to work on the front plane. Now you could see the change, right? This was a feature manager, it got switched here, and you have all the default things mentioned here, and automatically it switched to the property manager. So what exactly property manager does is, whichever the tool you're going to use, it will try to give you the inputs for that, just for information. Okay, now I'm using the sketch. I would like to select the front plane. Now you could see automatically the front plane got oriented to your face, normal to view, right? That is the setting is telling in the sketch, auto rotate normal view. Is that clear? If you don't do that manually, you need to do it. It is again a time consuming process. Okay, now I want to use the line tool. Now if I try to draw a line, you could see there is no input for the dimension, right? Can you see? I can simply draw it like this. Once you draw this one, you need to go to smart dimension. You need to assign the dimension. Assume I would like to have it 50. So it's a lot of clicks, right? So what we can do to avoid this is go to settings here, go to sketch and activate this, enable on-screen numeric input. Just click OK. Okay, now I'll just again activate the line. The shortcut is L. If you press well, the line tool will get activated. I'll simply draw this. You could see I have the on-screen numeric is active. I can define the value. Assume I would like to have it as 25. I can enter it. See, you could see there is a yellow highlight, right? It shows the vertical and horizontal relations. You can snap it if you want. Now you can see once I come here, it highlights to the origin. If I click here, it is exactly 50 mm, and it is horizontal and vertical to the relations, and you can complete this. Okay, now my question is that the sketch is fully defined?
Yes. No, we still do the. Yeah, I think so.
Yeah, because we have the origin here only. From the origin we have started. It has all the relations, and you could see in the status bar it is showing it is fully defined, right?
Yes.
Yeah. So now with this, the sketch is fully defined. Now once you're okay with your sketch, what you can do is you can exit the workbench. Can you see here? There's an icon to exit. You can click on this, or else you can click here, exit icon. Okay, both you can do it. Once you do that, I need to extrude it. I would like to make it isometric view. What you can do is you can go here, you can choose the isometric view from here, or else you can configure shortcut in I for isometric view. I'll show that later. Now if you want to extrude this feature, you can switch to features here, select the extruded boss, select the sketch. Okay, this is one way. You can even define the value here. Assume we would like to have it 30. I'll just take it up to here. I'll click green check. Okay, this is one way. Or else you can directly click on the sketch. Once you do that, you'll have this 3D instant tool. Okay, you can simply drag it and set the value how much you want. I would like to have it as 20. Set it. Okay, once you do the sketch, you can even change the dimension. Just need to click on the model, just double click on the dimension which you want to change and enter the value how much you want to have it. I would like to have it 30. Now it is not changed, right? You could see there's an icon to rebuild, means it is telling you need to update it. So I can click this icon here, or else you could see the shortcut Control B. You can press that. Okay, is that clear?
Yes.
Any doubts up to here?
No.
Yeah, so I think we can cover a remaining session in the next class. So I think today it's fine. So let me just take you through this slide. In a summary, we went through the basics of the CAD. We had gone through that, and then we seen the menu bar, command manager, task pane, heads up view, and the graphics area. We had seen few things in the system options. Okay, units I'll show you in the next session. customizing the user interface. Few things I had shown you. I'll show the shortcut bars, keyboard and the mouse gestures in the next session. And add-ins we had seen. The background, how do we need to configure, we had seen. Okay, is that clear? Any doubts up to here?
No.
Okay, so what we can do is next session tomorrow I'll have it. I'll try to cover the introduction to basic sketching. Okay, after that I'll give you 1 day time to practice everything and the sketches, or 2 days also is fine for me, and then we'll keep on moving. Yeah,
Sounds good.
okay then, so that's all from today's session. See you in the next session. Bye.
Yeah, thank you. Bye.